In this video, we will be setting up this gateway as a Modbus TCP client or master to collect data from this PUC as a Modbus TCP server and push it out on the serial port DB-9 in ASCII format. This is the Phoenix contact gateway. Modbus TCP ASCII. The order number is 2702768. This is the pinout for the DB-9 serial port RS232 DTE, RS422 485 4 wire, and RS485 2 wire. The 9 pins are here. The default IP 192.168.254.254, subnet 255.255.255.0. For the PUC or Modbus TCP server, its IP address is 192.168.0.120. Modbus function code 3. Slave or device ID is 1, and it has only 100 Modbus holding registers from 40001 to 40100. These 116-bit were Modbus holding registers are equivalent to 208-bit bytes that will need to be specified for message length in the gateway configuration. Let's use Ethernet cables to connect both the PUC and the gateway to my computer. The other ends of the two black cables go to the common Ethernet switch. And the switch is connected to my computer with this blue cable. For the serial connection, in the user manual of the gateway, page 11, I use this pinout to build my own cable. This is the cable I built. I don't have one 8-conductor cable, so I use two 4-conductor cables instead. One end will go to the DB-9 serial port on the gateway. And this end will go to the RS232 to USB cable first. And the other end of the RS232 to USB cable will be plugged into my computer. On the computer, first let's change the network adapter of the computer to make it on the same network with the gateway. Control panel, Network and Internet, Network and Sharing Center. The gateway default IP address is 192.168.254.254, so my computer IP address will end with 25. Okay. Okay. Close. Let's open a web browser. Type in the gateway default IP address 192.168.254.254. Enter. Username will be admin with capital A. And password will be admin or lowercase. Login. Now let's change the gateway IP address first. Let's change it to 192.168.0.254. Apply changes. Then let's go back to Network and Sharing Center to change the computer IP address. Now we need to change this to 192.168.0.25 for the computer to be on the same network with the gateway new IP address 192.168.0.254, and the PUC IP address is 192.168.0.120. Okay. Okay. Close. The gateway now has the new IP address 192.168.0.254. Username will be the same, admin with capital A, and password admin or lowercase. Login. Let's go to serial settings, port 1 configuration, RS-232. Let's change baud rate to 19,200. Apply changes. Modbus configuration. Change this to write to PUC master. PUC writes. Change it to POR PUC master. Uncheck this box. PUC IP address 192.168.0.120. PUC device ID 1. Port rate millisecond, change it to 1000. Message length in bytes. As mentioned earlier, this will be 200. Apply changes. For PLC master, read from PLC holding registers base 1. 1 here is Modbus holding register 40001 is where the gateway starts reading the data. The data is sent out of the serial port as a raw ASCII string. The data area is comprised of 16-bit words. The first word is the sequence number. The second one is the length header for transmit messages, and the rest is for the data to transmit. An updated sequence number indicates new data to transmit. Raw ASCII configuration. None. Apply changes. Now let's use Modscan 32 to check the Modbus TCP communication from the PLC. Connection. Connect. The PLC IP address is 192.168.0.120. Okay. Modbus function code 3 for holding register. Device ID 1. Holding register 40001 is the sequence number for the gateway to transmit or push the data out. The number has to be incremented. In other words, all messages are only transmitted if the sequence number has been changed. For that reason, the PLC increments the value of the holding register 40001 by 1 every second. Once it reaches 250, it will be automatically reset back to 0 and start over again. Holding register 40002 is the length header for transmit messages. Please note that the length is specified in 8-bit bytes, not 16-bit words. For those who do not know what a bit, a byte, and a word are, a bit, short for binary digit, is the smallest unit for digital information representing a single binary value, either a 0 or a 1. A byte is made up of 8 bits, and a word is made up of 2 bytes. The left byte contains the most significant bit, and the right one contains the least significant bit. The rest of the holding registers 40003 to 40100 is for the data to transmit. This is Modscan 32 as a Modbus TCP client, and this table is for the PLC as a Modbus TCP server. All the readings on Modscan 32 match with the logical values in the PLC. Now to see how the data is displayed as a string in ASCII format on the output DB-9 serial port, we will need to learn how the 16-bit word holding registers are made up. Each word is made up of 2 bytes, and each ASCII character is represented using 1 byte. This is the logical values for transmit data in bytes in the POC. We can see the transmit message length is 21. It goes from byte 1 to byte 21. Each holding register as a 16-bit word is made up of 2 bytes. One is with the least significant bit and the other is with the most significant bit. For example, holding register 40003 is made up of 2 bytes. The byte with the least significant bit, value of 10, is for live feed, and the byte with the most significant bit, value of 83, is for S, letter S. Another example, let's look at holding register 40004. The byte with the least significant bit, value of 89, is for letter Y, and the byte with the most significant bit, value of 32, is for space. And so on. The link for this website is in the video description. Now let's use hyperterminal to test the ASCII output on the serial port DB-9. That will be it for this video. Thank you for watching. If this video is helpful and you like the content of my channel, please like, share and subscribe. A separate thanks at the lower right corner is also a great way to show your support to my channel. Thank you.